Okay, in this section, I will talk about function and task. They are used for Verilog syntax to describe complex function. First, let's look at function. How to define a function? A function is defined using the keywords function and end function. So the function and end function describe the scope of this function, and you will give it a name. This is the function name, and you define the output data bitwise, the bitwise of output. Then you declare the function input signals. Okay, you define the function input signals. There may be at least one input and more than one input, but you can't give 0 inputs. That is, a function must have at least one input. Then you use the begin end to enclose all the statements in this function. That is the function body. This is the function body. You enclose all the statements inside this function using the begin end keyword. There is maybe several or many statements, such as if else case, for loop. Any procedural statement can be used here. So you can treat the function body as a procedural block. So in the function body, you can use any procedural statements such as case, if else, for loop. But assign is not allowed, okay? You can't use the assign keywords. Okay, this is used in continuous assignment. This is not allowed. And please pay attention to the function name. The function name is used as the return value. In Verilog, the function name is used as the return value of this function. So you can treat it as you have defined an output variable named as the function name. So you can assign value to the function name inside the body. And the function name is the only return value for a function. So function just has one return value and only one return value. Okay, that's all of defining a function. Then how to use a function? You can use a function by call the function name and give the input here. And you can use this function in anywhere of the right hand of assignment, such as in the procedure block, and you can use it also as the right hand of the assignment block, assign block. Let's summarize it. You use the function keyword and end function keyword with the function name and the data width of the return value. Then you declare the input signals here. There may be several inputs, but must have at least one input. Then you use the procedural statement to describe the function of this function. Then you can call the function anywhere and to the right hand side of any assignment. By the way, you can define some variables, some internal variables here. Yeah, before they begin, you can define some internal variable. So they are variable type. So you can just use the keyword rig, an integer, or something like that. Okay, to define the internal variable. Let's show you an example. So this is an internal variable for this function add. Okay, that is how to define your function. Something strange for function is the function name itself is used as the return value. Okay, let's say the define of the task. How to define a task? A task is begin with the keyword task and give a task name, then end with end task keyword. After the header, you can define the input and output signals here. Then you use the begin end keyword to enclose all the statements inside this task. This is the body, the task body. That will define the behavior of this task. Then you can use any statements that can be used in a procedure block inside the task body. And for task, you can have 0 or any number of output signals. And for input, you can have 0 or any number of input signals. Okay. And for task, as it can have any number of output signals, so the task value doesn't use as the return value. Doesn't use it as the return value. Okay. And you can see these signals are not defined. Yes, are not defined within this task. Yeah. Where does these signals come from? So these signals must be the signals defined in a module. Okay. Must be defined in a module. So in the module, you will define the signal here, and in the task, you can access these signals directly. For example, this is a function. I have defined the signal ABC here. Within this function, I can access the B, the variable B in the module, inside the module directly. So when the add function is called here, okay, the B value inside the function is the same as the B value inside the module. That is the value of B here. So the function called here, the b value inside this function will equal to 0, and the function called here, the b value inside the function will be 20. So let's summarize the components of the task. So you use the keyword task and give it a name. Then use the end task keyword. Then you define the input and output. Sorry. Also, you can define some internal variables here. Yeah, here. Okay, this is the component of task. And in task, you can say the invent wait statement is allowed in task. Yeah. The invent wait statement, such as the at policy clock, delay some time unit. The invent wait state can be allowed in task. But for function, invent wait statements are not allowed in function. So that means when you call the function, the time of enter this function and the time of exit this function is the same. For example, if we enter this function at 10 nanosecond, then we must exit this function at 10 nanosecond. But for task, if you call this task, and sometimes the entrance time for this function for this task may be different for the exit time. Yeah. When execute the last statement in this task, the task will exit. And for the input signals, when the task is called, this signal will latch, or you can say will remember the value that is put in, and keep the same within all the execution time of this task. That is, the input signal will never change for the whole time of the execution of the task body. Even the input signal outside the task has changed, it has no impact on the input signal inside this task. This is the same as the behavior of function call in C language. So let me show you an example. Okay, I have defined some variables E and F, and there is a task called test. The task function is just delay some time unit and display the value of E and F, while E is an input signal. So you can understand that E here must use the value of this input signal, but the value F is not defined inside this task, so it will find this variable from the upper level that is inside this module. So the F here will use the value of F here. Then we will change the value of EF in an initial block, and we will call the function. Okay, call the test task in another initial block. So what will be print for the value? What value will be print here? For example, the reset is 1 and 2, and after 1 nanosecond we call the task, and delay 10 time unit we display the value. But at the time of 10 unit, okay, the value of EF has changed. So when this line is called the task and display the value and to time unit 11, yes, and to simulation time 11, what's the value will be print here? E will be print 1 or 11. F will print 2 or 12. Okay, I have simulated. So this is the result. Okay, you can check here. So E is remembered, okay? So this E is the internal value E inside this task, and F will look upward, and F will look upward, and find the F value inside the up level module. So for the second call of the task is the same. And for the third call, as EF is never changed after that. And do you find something strange for the print of time? Yeah. You can see the first call the time should be 11 time unit, but the print value is 110. What's the matter? So you can see, you can understand it as we define the time unit as 1 nanosecond and the precision as 100 picosecond. So the time print here, or you can say the time returned by the time function, the time system call. The system function call, the value returned by this system function call is in the unit of precision, not in the unit of time unit. Okay. So this 110 is in the unit of precision of time scale. Okay, let's summarize the difference of task and function. For sensitive code, you'd better use function. And in function we can't have the wait statement, that is the invert wait statement in its body, such as wait for some signals, wait for the age, or you can use the wait keyword to wait for the condition to true, or to wait for the expression to true, and wait some time unit. These are all not allowed inside the function body, but these are allowed in task body. And for function, you must have at least one input, but task can have any number of inputs. And for function, you can just have one output, but for task you can have any number of output. This is the difference between task and function. And most important, you must understand that the entrance time for function and the exit time for the same function is the same. But for task, as there may wait statement inside the task, so the entrance time and the exit time for task may be different. That is, the execution of a task can consume some of the simulation time, but the execution of function can't consume any simulation time. Okay, I have given some statement for the difference of function and task, but this statement is wrong or right. This statement I gave for function and task is correct or wrong. How to verify it? Yeah, how to verify the correctness of this statement. I can also make some mistake. So for the study of language, okay, you can try it. For example, you can try to define a function without any input. Yeah, you just write some simple code. For example, here, you can just omit this line and change. You can say, make it simple. Okay. Then you can call this function. Yeah. Just write some simple code, sample code, and test it. And use the simulation tool to test it, and see whether the simulation tool will give you some error on the syntax. Yeah. Try it. This is a good way to learn language. Okay. And the Verilog language has defined some system functions and tasks, such as the time, real time. It will return the simulation time, and the fopen, fclose, fdisplay task. It will enable you to read-write files on your disk. So there is many functions. You can find them in the Verilog specification, in the Verilog language manual. Okay. So you can say the function and task is used to simple the coding effort. That is, a function may be used several times inside a module, or can be used several times in several modules. So you can define it once and use it many times. This will save you the coding effort. And if there is something wrong, or if there is some bugs in the function, so you can just modify one place and all the other places will be modified. Okay, that's all for task and function. In next section, I will show you an example of how to use task in test bench. It's a useful usage case. Thanks.